Good morning. We are starting our new unit today. It is Unit 2, which is all about the lithosphere. So today we're going to introduce the lithosphere and the rock cycle and start discussing what's going on inside the planet and how that leads to differences and changes outside the planet. So as before, we're going to have a central unit, central idea that goes along with this. You'll discover that as we go on, and we will do a concept map to go through these central ideas in class. But as we get started, we can look at the globe just like this, as if you chopped it right in half, and we're looking at the inside of the Earth. If we go from the outside to the inside, we've got 4 layers that we really are going to investigate. The furthest out is the crust, and that's going to be our thinnest layer. That's where we live. That's where we see the continents, the oceans, and things like that. The next one down is going to be the mantle, which is actually going to be the thickest layer. And on top of being the thickest layer, it is also going to contain the convection that leads to a lot of the motion on the crust. If we combine the crust and the mantle together, we end up with the lithosphere. So the lithosphere is just those top 2 layers. If we dig in one deeper, we end up with the outer core, which is going to be liquid molten metal that's rotating around the inner core, which is a superheated solid metal. What's important is that these 2 things, as we discussed in our last unit, create the magnetosphere, or the protective magnetic field that goes around our planet and protects us from solar wind. So real quick, one more time, we've got the crust, the mantle, the outer core, and the inner core. The crust and the mantle combined lead to the lithosphere. One more little add-in is when you look at the mantle, that's where all the convection within the planet takes place. Again, all of the convection that takes place inside the planet comes from the mantle, that convective movement, where hot things are going up and cold things are going down. One other thing that we need to think of is that when we look at the lithosphere from the outside going in, it's made up of a variety of different plates. We call those the tectonic plates. And the tectonic plates are something that we're going to look quite a bit at this unit, and how their interactions cause consequences that we visualize and that we experience. Now, if we continue to look, what we're going to see a lot of as well is the rock cycle. So if you look over here, you can see the rock cycle. The rock cycle is composed of 3 different types of rocks: igneous, sedimentary, and metamorphic. Okay, one more time. 3 types of rocks: igneous, sedimentary, and metamorphic. I like to start with igneous because I believe that they're the easiest to form, because they come from cooled magma that erupts out of volcanoes or out of the inside of the lithosphere in some way. So igneous rocks come from the cooling of magma that reaches the surface. If you take igneous rocks and you're looking to make sedimentary rocks out of them, what you have to do is to make sediments. And sediments are like gravel. They're smaller, broken down pieces. And to do that, we have to weather them, break them, rock slides, erosion, things like that. Once you have all those little pieces, what you need is heat and pressure to compact them into the sedimentary rocks. You can see when you look at sedimentary rocks like we will in class, all the different pieces and layers that go together as opposed to one homogeneous same piece. Now, igneous rocks can also be transformed into metamorphic rocks. Metamorphic rocks are the ones that require the most heat and pressure. When I say the most, I mean extreme amounts of heat and pressure, squishing, pushing, forcing it all together. So to take an igneous rock, you compact it, you squish it, and you end up with a metamorphic rock. Now, if we want sedimentary rocks to go into metamorphic rocks, you go through the same process. You take your already established sedimentary rock, you add tons of heat and pressure like you might find inside the earth, and you'll end up with metamorphic rocks. Now, what's important is that metamorphic rocks can go back and turn into igneous or sedimentary rocks. So to turn them into igneous rocks, you need to have them melt down inside the planet and erupt out as magma. To have them turned into sedimentary rocks, you have to have them broken down into pieces and then compacted back into the sedimentary rocks. So you see a cycle. We've seen a lot of cycles throughout our units in our course of study, and one way to help you study is to put more things into cycles, to study one piece at a time, and then study the interactions between them. To say, okay, if we continue to increase this factor, like we increase heat and pressure, what are we likely to end up with? Now, amidst all the things that we're looking at and all the things that we're going to be studying, we have to make sure that we focus on where the energy comes from to fuel this process, to fuel the movement in the inner and outer core. And where that comes from is from 3 main contributors. the convection inside the planet that comes from the inner and outer core and is seen in the mantle. That convection forces a lot of energy to come up in hot things and energy to decrease as they come down as cool things. Another key source of energy is the sunlight. The sunlight provides heat, it provides photons, it provides warmth for the planet to go through these processes. The sun also leads to the gravity that is experienced that helps compact all of these things together. So not just on the surface, but on the inside of the planet, that gravity helps force all those pieces together to make our rocks. So one more time, we've got three sources of energy: convection, sunlight, and gravity that all combine to help fuel the rock cycle and to help move the tectonic plates going through the planet.